Hello, this is Sean from Beyond Kinematics. We have prepared a video to demonstrate how the use of simulations and digital twins can provide tremendous value for real-time code development. In a typical machine commissioning lifecycle, control software development is very dependent on physical hardware, mechanical assembly, electrical wiring, and lead times of physical components. Components that need to be ordered, received, and then installed and integrated into the overall system. Unfortunately, with this approach, delays in the procurement, design, and assembly process translate into a highly shortened controls development timeline. Rather than a polished, robust machine, large amounts of technical debt are introduced into the equipment. If a project deadline is to be met and all other facets of the project are running behind, the controls development time gets shortened tremendously. What is arguably the most important process of machine development is relegated to the absolute shortest development time. At Beyond Kinematics, we advocate for a different approach. Imagine being able to develop your code offline on a CAD-accurate representation of your system. Motion control, physics, vision, and sensors can all be accurately simulated and interfaced with a real-time controller in this environment. With this approach, a robust and well-optimized machine can be realized and at a much faster pace. We believe this is the future of machine development. Felipe will demonstrate more about this approach in the following video.
Hi guys, this is Felipe with Beyond Kinematics. Let's check out this simulation. Here we have a scalar robot with a vacuum cup in the end of arm. We're going to be using vacuum to grab the products from this conveyor to the next one. This conveyor moves the products until they break this laser beam from this proxy sensor here. And when that happens, the product is conveniently located within the field of view of this camera, where we're going to take a shot of this QR code that's here on the side. This image will be sent to TwinCat Vision and we'll decode it. Next, I want to demonstrate the integration between my TwinCat project and the simulation itself. So let's run it. Let me go back to the scene. And as you can see here, I have the beam from this proxy sensor, and I want to move the product and break the beam and show you guys what happens here in TwinCat. So I have this variable here, bproxy conveyor 1, conv1. So by moving the transform of this object and breaking this beam, you can see that the state of my Boolean variable changes to true, as well as this LED light indicator here in the simulation. So you can see that I can change the state of the variable in TwinCat by obstructing this beam here in the simulation. The same thing applies to this sensor here. So in this case, the signal is mapped to this variable bproxy conveyor 2. So I'm going to move this container. Let's have a look at the HMI. Here I have the results of my vision. So I have the green, which corresponds to the contour of the QR code. Then I have the decoded string and the processing time. Notice that it only took 642 microseconds to decode this image. This is due to the fact that TwinCat Vision runs inside the controller, so there's no loss at all to transmit the result from the vision task to the PLC itself. Then I have my state machine, I have my XML state, and my execution state. In manual mode, I have the ability to send this to manual and, for example, jog the robot. Or I can manually actuate the conveyors, turn on and off the vacuum pump, do an absolute motion. And finally, here in events, I have a log of everything that happened with the machine. So if I double click this last item, this will tell me the manual mode has been enabled. So I never this is my last event, I never disabled it. So it was enabled at this time and date. And this is very important. This is the source, the exact spot in the code that originated the message. So if I'm troubleshooting a problem, I have the ability to go exactly to the POU that is throwing the exception.
All right, so the next thing that I want to do is to create logic to handle the fact that sometimes the camera cannot read the QR code. To simulate that problem, I will rotate this first item. So now this blank face is pointing to the camera. Now, we will need to create logic here in the PLC to handle that situation. And I basically want to do two things. So first, if I can't read the QR code, I want the product to continue on the conveyor, and it will eventually be conveyed out of it. And in the end of it, we will have a reject bin, and the product will fall over that reject bin. And the second thing that I want to do is tell the operator, tell the log, that I could not read that barcode. Coming back here to the PLC, I'm in the execute state of my FB pick and place. This FB pick and place contains the PackML state machine, and inside the state execute of that state machine, I have another state machine that handles the sequence, right? I have a state here called read QR code, and in this state, the vision task will be called, and we will get the S code from the vision task. This S code is the decoded string. Here, currently, we have one transition, and we are going to the pick state. What I want to do is have a second transition that will take my machine to a state where we can properly deal with this unwanted product. First thing that I need to do is declare another enumeration for this extra state. So in this extra state, I will be indexing the conveyor number 1 just to get the product past the proxy sensor. So let's do that first. I'm going to go to the definition of my state, enumeration, and I'm going to create a state called index conveyor 1. So now that we have this state, here I need to create a transition. If I'm triggering the vision task and my vision task is done and the result is null, then I will transition to my newly created state, index conveyor 1. And I will change this transition. I will add this. So now basically, if my decoded string is different than null, then I'll do this, and I'll go to pick. If my decoded string is null, then I go to this state. So let's implement this new state. I'm gonna pretty much do the same thing that I did here in the beginning, but I'm gonna negate that. If the proxy is triggered, then I will drive the conveyor with a speed of 0.1 meters per second. Otherwise, I will stop it. And when I stop, I will create a transition back to the get ready state. Now, the next thing I want to do is create a message here. if I'm going this route here and going to this index conveyor 1 state, I also want to issue a message. My FB pick and place is extending a event system function block that I created. My method create message. Scar pick and place. And my first event here is cannot read QR code. If this is triggered, then I will create this message. And then I will go to this state here, index once, and go back to my get ready state. Let's build and download. So let's test that. And yeah, I got the message, but there's something wrong with my state machine. So now I'm pretty much rejecting everything. So let's go back to the code and see what's wrong. So here I can see that the states are going through get ready, index conveyor 1, and read QR code. So it's just flying through this state here and looping back to get ready, and for that reason it's rejecting every product. So which tells me that the vision is not resetting, and it's because I forgot to add these lines. So if we add this, all right, so it rejected that product, the first one, and it picked the second one, and we have a nice message here in the event logger. And this is the beauty of having a digital twin to do offline PLC development. Now I can afford to make all these mistakes, learn with them, and improve my code before I even have any hardware. I hope you have enjoyed this video. We have shown how to leverage digital twins to do offline PLC programming. This infrastructure is so powerful and can be used during the entire life cycle of a machine. The proof of concept, the development, like we saw here. Once the machine is delivered, you can use it to train your maintenance crew and decrease downtime, or rapidly implement changes without bringing the machine to stop. For example, adding a third conveyor. Beyond Kinematics is focused on offering digital twin development services, but we can also support your project PLC, HMI, vision, robotics, motion control, and data acquisition needs. Don't hesitate to reach out if you need support in any of these areas. We'll be happy to talk and see how we can bring value to your venture. Thank you.